This one is one that I want to talk about with you. Not as straightforward as the previous two examples, three examples we've looked at. Let R be the region bounded by the graph f of x equal to x, the x-axis over the interval from 1 to 2. This is the x-axis, this is the y-axis. This is the line y equal to x. Here's 1, here's 2. Find the volume of the solid of revolution generated by rotating R about the line x equal to -1. So the x values are along the x-axis. Here's x equal to -1. Here's our first example. Where we're not doing it about an x-axis or a y-axis. So we're going about here. Okay, let's do this. First question, is this a dx or dy?
dx.
Ming Hui says dx. Steph says dy. Well, we want to chop up parallel to the axis of rotation. Picture looks something like this. When I draw this picture, do any of you guys want to change your answers? No. So the way I've drawn this picture, if I chop it up like this, to me, that looks like that little bit of thickness right here lies on the x-axis. So I think it should be a dx. So I'm going to set up my integral. It's going to be a dx integral. According to this picture, what's the smallest that x could be? 1. What's the biggest that x could be? 2. It's going to be 2 pi times the radius times the height. The distance from here to here, let's say that we're looking at this shell right here. The distance from here to here is x. But my radius goes from here all the way to here. In other words, my shell is bigger than if I had rotated about the y-axis. So we also have this extra distance from here to here of 1. So what do you guys think I should put for my radius right here? You guys like multiple choice? The choices are x minus 1, x plus 1, or x. I see we already have 2 votes for x plus 1, 3 votes for x plus 1. That is correct. So in the old days, when we did about the y-axis, the radius was x. But because we shifted the axis of rotation, the radius is x plus 1. What do you think the height of my shell is going to be? The height of the shell is, why is it not -1? So this distance from here to here is x. If you did x minus 1, that would put you right here. That would make the distance, that would make the radius this. We want the radius to be this whole thing. So while it's true that this x value is -1, I don't care about the number, I care about the distance. The distance is 1. Does that make sense? So it's going to be 1 plus x. Okay, good. A student asked me, privately messaged me and just said that briefly. I hope you guys can see the height is unaffected. The height is just going to be x. That's the function. So this problem now becomes the integral from 1 to 2 pi x plus 1 times x dx. That's equal to 2 pi times the integral from 1 to 2 x squared plus x dx. It's going to give us 2 pi x cubed over 3 plus x squared over 2 from 1 to 2. It's going to give you 2 pi 8 over 3 plus 2 minus 1/3 plus 1/2 units cubed. If you're pressed for time on your test, just leave your answer like this and go back at the end to simplify it. I don't want you to waste 5 minutes trying to simplify this when the calculus is long done at this point. Okay. But do plug in the numbers. All right.